Welcome to this session on separable equations. So in this problem, you're asked in the first question to solve the initial value problem, dy dx equal y squared, with the initial condition y of 0 equals 1. In the second part of the problem, you're asked to find the general solution where no initial condition is imposed. So here you need to remember your method of separation of variables to tackle the first question. And then in the second part of the problem, remember all the type of solutions and conditions that you applied in the first part to recover the lost solutions. So why don't you take a minute, pause the video, work through the questions A and B, and then we'll continue together when I come back. Welcome back. So in the first part of the problem, we'll be solving the equation dy dx equal y squared. So here the method of separation of variables tells us that we should regroup the variables of the same kind, so all the y variables in one side and dx variable on the other side of the equation, and then integrate from this point. So here for this step, notice that I divided by y squared, which means that we need to impose the condition y not equal to 0 from now on. So from this step, we just use indefinite integrals to integrate both sides of the equation. So the left-hand side is the integral of dy over y squared. So integral of this gives us minus 1 over y. And the right-hand side, integral of dx, is just x. Both sides would give us constant of integrations, but we only need one because this is a first-order differential equation. And so we group them together on the right-hand side with constant c. So from this point, given that we're interested in variable y, we need just to inverse the expression. And that gives us partial answer, which is y of x equals minus 1 over x plus c. So now we need to use our initial condition, y of 0 equals to 1, to determine the value of c for this particular initial value problem. Oops. So our initial condition was y of 0 equals to 1. So if we substitute this in the expression that we just obtained, we just have 0 plus c, which then only gives us c, equals to 1. So we end up with a value for our constant of integration, c equals to minus 1. And so the solution to this problem is y of x equals 1 over 1 minus x. So if you examine this expression, you see right away that we have a problem for x equals to 1. Because at x equals to 1, we have a 1 over 0, which means that then the solution blows up, and we have a vertical asymptote. So let me draw this here. So we're going to have an asymptote on x equals to 1, and a solution that passes through our initial condition y equals to 1, going to infinity when approaching x equals to 1. But then on the right side of the value x equals to 1, we also have another part of the solution that goes to 0 as x goes to infinity, and that diverges to minus infinity when x approaches 1. So by convention, the solutions of differential equations are defined on one single interval. So we need here to realize that the solution we had is basically two parts, the parts on the left of the asymptote and the part on the right of the asymptote. So the solution to our initial value problem needs to be the solution that passes through the imposed initial condition, which was y of 0 equals to 1. So it needs to be this solution. So now, if we move on to the solution of the second part of the problem B, we were asked to find the general solution of the problem, which means that we need to account now for all the solutions regardless of their initial condition. So we already answered this partially during the solution of part A, where we solved using indefinite integrals and arrived to the solution minus 1 over x plus c, where here we had basically an undetermined constant of integration. So this is one general solution. But remember that we need to give all the solutions of the problem. So when we arrived to this solution, we excluded the solution that y equals to 0, which was basically a lost solution, because we had to impose the condition y non equal to 0. So we need, when we give the general solution to this differential equation, to recover the lost solution. And then we basically have one kind of solution, minus 1 over x plus c, that excludes y equals to 0, and another kind of solution that is simply the 0 solution. So to summarize, the important points of this problem is to remember the separation of variables and how to use it, and the fact that using it imposes conditions that require us to recover lost solutions at the end of the problem if we're asked to give general solutions. Another point to remember is that even a simple ODE can lead to relatively complex behavior, such as the presence of this vertical asymptote that you need to then know how to deal with and determine which part of the solutions that you obtain is the real solution to the initial value problem that you're given.